this question is something that you kind of see on the SAT, on the ACT, even on the subject tests. It's not really particular to any test, but I think regardless, it illustrates a good logical principle and it illustrates a strategy to tackling some of these logic questions. So regardless of the test you're taking, I recommend give this question a shot, and then we'll talk about it. All x's are y's, but not all y's are x's. Some z's are y's. If the above statements are true, all the following statements must be true except. So 4 of these statements, given that these statements are true, 4 of these statements are also going to be true, and in fact must be true. One of them does not have to be true. Maybe sometimes it could be true, or maybe it never could be true, but the point is it doesn't have to be true, and that's the statement we're looking for. So you could tackle this logic question kind of in your head, like almost picturing, okay, all x's are y's, and then not all y's are x's, and then some z's are y's, and then you can think of these statements and see if they work with the above and think it in your head. But that's super confusing. You can get easily lost in the x's and the y's and the z's and the sums and the nots and the nevers and the alls. And what I recommend for questions like this is to do a sketch, basically Venn diagrams. Venn diagrams can really help you here to at least see what you're given and then see what the possibilities are for your choices. So how does this work? All x's are y's. So every single x is a y. So what I'm going to do is I'm going to draw a circle, and this represents my y's, right? So you can think of all of your y values or y elements of the set, or however you want to put it, are in this circle. And if all x's are y's, then that means inside of this circle completely is another circle, which is x, right? Every single x is also contained in this y circle. Now we are told, by the way, we're also told not all y's are x's. So that tells us that, for example, x and y aren't just the same circle, that the y circle is bigger than the x circle. Because here we've got x's that are y's, but we also have some y's, right? Here, 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 here. We also have some y's that are not x's. The second statement says some z's are y's. Now here is where you have to be careful. Some z's are y's. So you could draw it like this, and here are some z's, and there are some y's, right? But notice it says nothing about whether z's can also be x's. So you also could imagine we could draw this like this, perhaps, where not only are some z's y's, but also some z's are also x's. So we're not 100% sure which way it's going to go. Is it this or is it this? Keep that in mind as we evaluate the choices. So some y's are not x's. Does that have to be true? Yeah. Notice here are some y's that are not in the x circle. So A is true, we can get rid of it. Some y's are z's. So again, we were told that some z's are y's, which must mean, therefore, that some y's are z's. That goes together. And that doesn't matter whether we draw it like this or whether we draw it like this. There will always be some y's that are also z's. So we can get rid of B. Some z's are not y's. Well, yeah, they tell us that some z's are y's, so we can maybe draw it like this, but that implies that there are some z's that are also not y's, right? There are some z's that are outside of the y circle. And again, that's true regardless of how we draw this, right? Here are some z's that are not y's. You might say, well, what if we drew it like this or like this? The problem there is it didn't say all z's are y's. It said some. So for that reason, we can get rid of C because C is true. Some x's are z's. So here it kind of comes to where we started previously when we were drawing this picture. We don't know whether some x's are z's or not. If we drew it like this, where some x's are y's, in this case, there would be no overlap between the z and the x. But if we drew it like this, there would be overlap. So since we don't have more information to tell us how we would draw this, we can say that yes, D is, we don't know if it's true, so it doesn't have to be true. So it looks like D is going to be our answer. No x's are not y's. Well, this is really just rephrasing the original statement. Notice if all x's are y's, then there can be no x that isn't a y, right? All the x's are contained in the y circle. So E must be true, and our answer here must be D. So just a useful way to sketch out your logic, sketch out your Venn diagrams, and see the possibilities rather than trying to deal with it in your head and get all confused about what statement is what and how they all fit together. Visualizing it definitely makes a big difference. To learn more about Reason Prep's SAT, SAT subject test, and ACT video courses, go to reasonprep.com/enroll, and you can find the link in the description below the video.